The continuation of Parabola. Pre-Calculus Quarter 1, Module 2, Part 2. The standard form of the equation with a vertex with the coordinates h and k. For a parabola with the axis of symmetry parallel to the x-axis and vertex with the coordinates h and k, the standard form is the quantity y minus k squared is equal to 4p times x minus h. You have observed that if the parabola, the axis of symmetry is parallel to x-axis, if the y variable is squared in our given equation. So, if p is greater than 0 or p is a positive value, then the parabola opens to the right, as shown in the figure number 1. If p is less than 0 or p is a negative value, then the parabola opens to the left, as shown in the figure number 2. The equation of the axis of symmetry is y is equal to k. The coordinates of the focus are h plus p and k. The equation of the directrix is x is equal to h minus p. The endpoints of latus rectum are h plus p and k minus 2p and h plus p and k plus 2p. Example number 1. Determine the vertex, focus, directrix, axis of symmetry, endpoints of latus rectum, the opening of the parabola with the given equation, and sketch the graph. Given an equation of a parabola, which is the quantity y minus 2 squared is equal to 4 times the quantity x plus 3. You have observed that this equation of a parabola is already in the form of the quantity y minus k squared is equal to 4p times x minus h. Now, to emphasize the values of k, p, and h, so we're now going to rewrite this in this form. So, the quantity of y minus 2 squared is equal to 4 times x minus, so negative 3. Then you have observed that the coefficient of the x variable is 4. So, we need to equate this to 4p. So 4 is equal to 4p, then find the value of p that will satisfy to the given equation. Then we have 4 is equal to 4 times 1. Therefore, the factors of 4 are 4 and 1. So we're now going to replace this to our equation, which is we have the quantity y minus 2 squared is equal to 4 times 1 times x minus negative 3. So we have now the values of k, p, and h. So since we have now the value of k, which is 2, p is equal to 1, h is equal to negative 3. Now, we can now find the opening of the graph by simply looking to the value of p. You have observed that p is positive 1. Therefore, the opening of the parabola is open to the right, or parabola opens to the right. The vertex at the coordinates h and k. So since h is negative 3 and k is positive 2, okay, just substitute the values of h and k. So we have the vertex at negative 3 and 2. Focus at the coordinates h plus p and k. So substitute the values. We have negative 3 plus 1 and 2. So then negative 3 plus 1 is negative 2. And copy the value of k, which is 2. Therefore, the focus at with the coordinates of negative 2 and positive 2. Directrix is x is equal to h minus p. So, x is equal to negative 3 minus 1. X is equal to negative 4. The axis of symmetry, y is equal to k. So, substitute the value of k. Therefore, the axis of symmetry is y is equal to positive 2. Endpoints of latus rectum. So we have h plus p and k minus 2p. So substitute the values. We have negative 3 plus 1 and 2 minus 2 times 1. Then just get the operations. Simplify negative 2 and 2 minus 2, or we have one of the endpoints of the latus rectum is negative 2 comma 0. The other endpoint, we have h plus p and k plus 2p. So substitute the values. We have negative 3 plus 1 and 2 plus 2 times 1. Then we have negative 2 and 2 plus 2. Then the other endpoint of the latus rectum is, or with the coordinates of negative 2 and positive 4. The endpoints are negative 2 comma 0 and negative 2 comma 4. The length of latus rectum is absolute value of 4p. Since the value of p is 1, therefore the absolute value of 4 times 1, which is equal to the absolute value of 4, and that is 4. And the length of the latus rectum is 4 units. Sketching the graph. Since you already know that the parabola opens to the right, let us now plot the important parts of the graph of a parabola. Let us start with the vertex at negative 3, comma 2. So plot negative 3 and positive 2. Then the coordinates of focus, we have negative 2 and positive 2. Okay, negative 2 and positive 2. Then directrix is x is equal to negative 4. So therefore, this is a line, a broken line. Since x is equal to negative 4, hahanapin natin ang negative 4 sa x-axis. Then we will draw a vertical line. So that is now the directrix of the graph of a parabola. Then, the axis of symmetry. So you have observed that it is also a line. Y is equal to 2. So hanapin natin yung 2 sa y-axis natin. So positive 2, then we will draw a horizontal line, a broken line. So you have observed it passes to the vertex and focus of the graph of a parabola. Then the endpoints of latus rectum. So we have negative 2 comma 0. We will now plot this. Then the other endpoint of latus rectum with the coordinates of negative 2 and positive 4. Then we can now draw the graph of a parabola by connecting, okay, one of the endpoints of latus rectum to the vertex, then to the other end point of the latus rectum. Then the length of, before that, the equations of the graph. Again, this is now the graph of the quantity y minus 2 squared is equal to 4 times x plus 3. Then the length of latus rectum is 4 units. Example number 2. So given the equation of a parabola, which is the quantity y plus 3 squared is equal to negative 16 times x plus 2. So now, to emphasize the values of k, p, and h, we're going to rewrite in this form. So the quantity y minus negative 3 squared is equal to negative 16 times the quantity x minus negative 2. Since negative 16 is equal to 4p, so find the value of p that will satisfy to this given equation. So we have the value of p that will satisfy to this equation is negative 4. Therefore, negative 16 is equal to 4 times negative 4. So therefore, the factors of negative 16 are 4 and negative 4. So we're now going to replace this to negative 16 in our equation. So we have the quantity y minus negative 3 squared is equal to 4 times negative 4 times x minus negative 2. Then we have now the values of k, p, and h. So the value of k is negative 3, the value of p is negative 4, and the value of h is negative 2. Since you already know the values of h, k, and p, do you think ano naman kaya ang opening ng graph ng ating parabola? Tama. Since P is negative, then the parabola opens to the left. Then we're now going to find the vertex. The coordinates of vertex, we have -2 and -3. How about the focus? Okay, the focus, the coordinates are -6 and -3 by substituting the values of HP and K. Then the directrix is, since x is equal to h minus p, by substituting the values of h and p, so we obtained x is equal to +2. And that is the equation of the directrix. While the axis of symmetry, substitute the value of k, then we have y is equal to -3. So this is now the equation of the axis of symmetry. Endpoints of latus rectum. So using the given formula, substitute the values of HP and K. So we have -2 plus -4 and -3 minus 2 times -4. Then simplify, you have -2 minus 4 and -3 plus 8. Then we have -6 and +5. So this is now one of the endpoints of the latus rectum. Then the other endpoint, we have -2 plus -4 and -3 plus 2 times -4. Then we have -2 minus 4 and -3 minus 8. Then we have -6 and -11 are the coordinates of the other endpoint of latus rectum. Then the endpoints are -6, 5 and -6, -11. The length of latus rectum is the absolute value of 4p. So since p is -4, therefore the absolute value of 4 times -4 is equal to the absolute value of -16. So therefore, the length of the latus rectum is 16 units. Let us now sketch the graph of a parabola. So since we already know the opening of the graph, since it is opens to the left, then the vertex at -2, -3. So we're going to locate that in our Cartesian plane. -2 and -3. So nasa third quadrant. Then the focus at -6, -3. So -6, -3. Then the directrix is x is equal to 2. So since x is equal to 2, it is a vertical line. So hanapin natin yung +2, then we're going to draw a vertical line, broken line. Okay. Then axis of symmetry, y is equal to -3. So since it is in the y-axis, which is -3, so we can draw or hahanapin natin yung -3 sa y-axis at we will draw a horizontal line, broken line. Okay, now you have observed that this line passes to the vertex and the focus of the graph of a parabola. Then we have the endpoints of latus rectum. So we will start with -6, 5. So -6 and +5. The other endpoint, we have -6 and -11. Then we will now draw, or we will now connect the endpoints of one of the endpoints of the latus rectum to the vertex to the other endpoints of the latus rectum. So we have now this graph of a parabola. So this is now the graph of the quantity y plus 3 squared is equal to -16 times x plus 2. Then the length of latus rectum is 16 units.